Today we are going to look at another topic which is basically more into the engineering maths, or you can say further maths, and we are looking at the topic on non-homogeneous differential equation and solution of that using Laplace transform or LT. Okay, so that's what we are going to do at. Under this we're looking at type 3. Okay, so I'm gonna say here as type 3. So this is type 3. We have three different type of cases when we're solving non-homogeneous differential equation. So there's type 1, type 2, type 3. All depend on the quadratic equation. So if you get the roots real, unreal, and imaginary, so those things define what type of different solution you are going to do and what kind of equation solution you're going to get. So all depend on these types. So we're looking at type 3, which we call as a complex roots. So when the equation, when you have a quadratic equation, and that gives you the roots as a complex root, you're gonna have a different way of dealing this non-homogeneous differential equation. I'm gonna talk about in a minute when I'm gonna show you basically what I'm talking about, what kind of roots I'm talking about. Okay, so before we start doing anything here, let me write the question here. So the question here is given as d square y over dt square minus 6 dy over dt plus 25y equals to 50. And the initial condition also need to be provided when you are solving differential equation. So the initial condition is given as y0 is 0 and y first derivative 0 equals to 1. So these are the initial condition. Right, so when we're solving any differential equation using Laplace transform, we need to have a formula of Laplace transform. So I have this website here, and yeah, you can find this formula in any website basically, but this one is good. So today I'm going to use the formula number 1, and then I'm going to use later on formula number 19 and 20, and again I'm going to use formula number 35 and 36, which I'm going to show you in a minute. All right, so how to solve differential equation which is complex root using Laplace transform. So let's do the solution then. Solution. So solution, first what we are going to do is, let's write a differential equation which is given us, which is dy over dt square. Remember, this is second order differential equation. You can see the order here is d square. When you have a square, that clearly means it's the second order differential equation. So d square y over dt square minus 6 dy over dt plus 25y equals to 50. So we have this differential equation. So first thing what we are going to do is apply Laplace transform on both sides. So apply, or we can say applying Laplace transform on both sides. So if we do that, let's use the symbol which is L, stand for Laplace transform, d square y over dt square, and then we have whenever you have a constant, you can throw that constant outside of the Laplace. Okay, and then just whatever you have the variable, you can just use the Laplace for the variable. Similarly, you have const 25, and then you have Laplace of y, and then you have Laplace of constant, because no variable is there. So let's see what is the formula we have to use. The formula we have to use, as I said, is number 1. Number 1 is constant. So constant Laplace is 1 over s, constant over s. And then going back to this 35 and 36, you can see dash or prime refer as your first order differential, first order derivative, and 36 is second order derivative because it has 2 prime there. And that's the formula, for first order differential, and then that's the second order differential. So that's the formula. So let me write here in terms of y. The formula is written in terms of f. So the first formula we are going to use is Laplace of constant. Okay, so Laplace of constant is going to be nothing but constant over yes. Okay, which you can see in our case here is 50. In our case here is going to be 50 over yes. And then another formula we will need to use is a derivative. So the derivative f, which is your prime, first derivative is, if you look again the formula, first derivative here 35 is yes f in a capital letter and then f0, which is initial condition. So same thing going to be happen here. We have yes and the capital Y I'm going to use. I'm not going to write in a bracket yes because capital Y stand for frequency domain, so I'm not going to use that. And then minus, you have y0 initial condition. Okay, similarly we have for double derivative, so I'm going to use double derivative here, or double prime, or double dash, you can see it. And then we have s square y, capital Y, minus yes, your first you can say first condition, and then minus your y dash 0. And let's see the formula again just to confirm. And yes, so yes f0 and f dash 0. So so once we have this information, we know if you look the question here, the initial condition is 0 and f dash 0, which prime is given. So this value here is going to be 0, so we don't need to worry about that. So this value is also going to be 0, but this value is going to be 1. So let's use in our Laplace. So our this equation here, the first one is going to be s square y minus 1. Okay, because of this first term with the double derivative. Then we have 6, then we have minus 6, we have minus 6, and then we have this only for the first derivative, which is going to be sy. Okay, then plus 25 y, anything which is variable is going to be just capital Y, because that was a small letter y and it's going to be capital Y now, equals to anything which is constant is going to be 50 over yes. Right, so once we have this, we can transform this minus 1 to other side, and we'll get s square y minus 6 sy plus 25 y equals to 50 over s plus 1. And in left hand side we can take y common, because you can see everywhere is y, so we can take y common. So if we take y common, we'll get s square minus 6s plus 25. And this side we can make a single fraction, because there is 50 over s plus 1. So whenever you're solving those kind of thing, remember your basic math class, how to solve or how to make this fraction as a 1. So it's going to be simply 50 plus yes divided by yes. Okay, so that's how you're going to get that on your right hand side. So what we can do now furthermore here, we can throw this all the s square minus 6s plus 25 to other side. We are going to get y equals to 50, or let's put yes in first. We'll get yes plus 50 divided by yes times s square minus 6s plus 25. Okay, now this is what I was talking about in the type. I was talking about the type. If you remember, the topic is type 3 complex root, and this is the reason. This expression here, or this quadratic equation, is going to give us the roots. If you check in a calculator, we are going to do that in a minute. The roots of this equation or quadratic equation equation, all right, is going to be imaginary. Okay, I will show you what I'm talking about. So remember, is a value is 1, b value is -6, and 25, c value is 25. So if you go to the mode and then find the solution here, which is, you can see polymole degree 2, and let's put the value. So a value 1, b value is -6, and c value is 25. So once we put the value of a, b, c in the equation, in the calculator, we can see the value here is imaginary. So 3 minus 4i, which is complex, basically complex number or imaginary roots. So any imaginary roots are put in the categories of type 3, which is complex root, and they have different techniques to solve this kind of question. Now when we're solving this kind of question, we need to do next thing, or next step which we need to do, is applying partial fraction. So let's do that. The only reason we need to apply partial fraction, so that we can separate this fraction, and if you go back to the formula, so that we can get a structure something like this, which is number 19 and 20. So if we can find the structure like this or this or this, then we can apply anti Laplace, and we'll get the answer in cos, or exponential sine, exponential cos, so something like that. So that's why we need a structure like this. To get a structure like this, we need to apply partial fraction, and that's what we are going to do here. Okay, we are going to break down this fraction, and once we get that appropriate structure fraction, we're going to apply inverse Laplace, and we are going to get our answer in back to the time domain. So now we are going to apply partial fraction. So let's do partial fraction. You don't need to follow exactly what I have done here. You can use your own method of partial fraction if you basically know how to do the partial fraction. But if you don't know, then please follow me here. So first thing we are going to do is we are going to write what is known to us, which is this expression, or you can say this fraction, -6s plus 25. And then we are going to break down, because remember, we need to break down this into different fraction. So we'll say here, whenever you have remember, this is a trick, okay? Whenever you have imaginary, we must follow this structure, which is a over s plus bs plus c over s square minus 6s plus 25. So remember this section here, okay? This is how you need to follow. This yes, which is just a over s, this sometime you might have a yes there, or sometime you will not have. But this thing, if you have imaginary, you can always apply this as as plus b. If you don't have that, then just, if you have already s in here, then you just use this format. Now we need to find the value of a and b and c, okay? Now to find the value of a, b, c, let's do this one by one. First, let's find the value of a. Now to find a, is straightforward, is really easy. All right, what you have to do is you have to say a equals to, you need to use this partial fraction which is given to you, which is s plus 50 divided by s times s square minus 6s plus 25. And then what you have to do is you have to multiply what is on bottom of a, which is yes, and then you can cancel this s and this s, and so left over is s plus 50 divided by s square minus 6s plus 25. Now once you have this, then you can put only for this condition, only for when you're finding a, okay? Then you have to put whatever is dividing by a, Whatever is dividing by a equals to 0. In our case here is simply s. So s equals to 0. If you have a different there, which is s minus 1, then you have to say s minus 1 equals to 0 and s equals to 1. So in that condition, you have to put s equals to 1. So for right now, since we don't have s minus 1 equals there, so we have simply s, we're going to put s equals to 0. And we are going to get a equals to 50 over, you have s square, which is going to be 0, and 6 times s is going to be 0. So 50 divided by 25, which is going to be 2. So we got the value of a, which is nothing but 2. Now we need to find b and c. So for now b and c, what we have to do is we have to simplify this fraction, and then we need to compare the coefficient of higher order. So that's what we are going to do. Now to find b and c, all right, what we are going to do is we are going to use the same expression, which is s, or same fraction, the main fraction, s times s square minus 6s plus 25, and then we'll take this side, which is, you can see, which is a s, this thing here. Okay, we're going to use this thing here on our left hand side. So a equals to a over s plus bs plus c over s square 6s plus 25. So our right hand side is absolutely fine. We don't need to do anything on right hand side. We're just going to repeat the same thing. But in our left hand side, we are going to take the LCM and basically combining these two fraction into a single fraction. And for that, we simply take the LCM of both fraction and multiply them together like this. Okay, and whatever is not in corresponding denominator, we're going to multiply with them. For example, in the a over s, we don't have this whole thing, which is s square minus 6s plus 25. So we'll multiply a with that whole LCM of the another fraction. So it's going to be a times s square minus 6s plus 25. Okay, plus we have this bs plus c on this side, but we don't have yes here because you already have s square minus 6x plus 25 in that fraction. What is not there is yes. So this is the easiest way to combine any fraction if you have two different fractions into one fraction. Okay, remember this technique is very handy. So again, your right hand side, we do nothing, we keep as it is, and then let's simplify our left hand side. So we'll get, let's open the bracket here. So when we open the bracket, we'll get a s square minus 6as plus 25a plus same thing we can do here, open the bracket, we'll get b s square plus c yes. Okay, and then divide by yes times s square minus 6s plus 25. Now one thing you can see here, because since this left hand side must be equals to your right hand side, we can say this value and this value can cancel out each other, they are same, and the leftover is going to be on left hand side and right hand side is going to be s plus 50 equals to as square minus 6as plus 25a plus bs square plus cs. So once we get this, now we can compare the coefficient. Remember, coefficient means if we are comparing the coefficient of s square, then this is the coefficient. Okay, this is the coefficient, means the front value, whatever value it has in the front. If you're looking at s square, then it has a, and where is another s square, which is b. Okay, so that's what we're going to do. Then okay, comparing coefficient of s square on both sides. So on your left hand side we don't have any s square there. So since we don't have anything on left hand side, we say 0. Whatever right hand side, we have a plus b. Okay, if you take s square common from there, you are going to get a plus b. So since we already have the information about a, that means b is going to be minus a, which is going to be minus 2. So b is nothing but minus 2. So we got our value of b as well. Now we need c. Now to get the answer for the c, again we are going to compare. Again, comparing coefficient of yes, this time just yes on both sides. Okay, on both sides. So if you look the equation, we have yes here. Okay, so on the left hand side we have 1 equals to, on right hand side what we have a 6 minus 6 a, and then c plus c. So I can write this as a c minus 6a, right? Because if I take yes common, I'm going to get c minus 6a. Right, so c equals to what then? C equals to 1 plus 6a. Since I have the information about a, I can say c equals to 1 plus 6 times 2, which is going to be 13. So the value of c is 13. So that means we got all the value needed, which we got a value, we got b value, and we got c value. So our partial fraction, y equals to is going to be a over, right? So let's write what is we have mentioned, which is bs plus c over s square minus 6s plus 25, and let's write this. A value is 2 over s, b value is minus 2s, plus c value is 13 over s square minus 6s plus 25. Right, once we get this format or this fraction, let's go back to our formula and see which one is matching. So far you can see here the 20 and 21, the structure is something like this. So the easy way to get a structure like that, s minus a whole square plus b square, is if you, whenever you have a imaginary, you can convert basically this section and get that s minus a whole square, and this section we can get that as a b square. Okay, we can divide that. Let's see how to do that. Y equals to 2 over s plus forget about the denominator, top portion for a minute. Just focus on the numerator here. So we are going to get s square. So I can say here is 2 times 3. All right, 2 times 3, I'm going to get a 6, and times yes. So I have yes here in front, so I don't need to worry about yes, but I don't have a 3. So I can say here is 3 square, like that. So since we have a 25 here, since remember we have 25 here, if I take 9, if I take 25 with 9, because I have 9 here, okay, remember 3 power 2 is 9. So if I 3 power, because I'm breaking that basically 25. Let me write a little bit nicely. I'm breaking that 25 into 9 and remaining portion. Okay, yeah. So if I break down basically 25 and 9, I'm gonna get basically 16 and 9, which is quite nicely, it works perfectly fine. So I'm gonna get here 16. All right, let me use white color. Plus 16. So technically I'm breaking that 25 into 9 and 16. Okay, so I will get y equals to 2 over s minus 2 s plus 13 divided by, so that means if you just look at this section here, this is kind of a square plus b square formula, or a square minus b square formula. Okay, so it's gonna give me s minus 3 whole square, and whatever left over is plus 16. Okay, all right, so once I have that, I can go further over 2 over s plus minus 2s plus 13. And then you can see here the format which we're looking. So 4 is nothing but 4 power 2. So if you look the formula here, it is matching with this format. Right, s minus a is your, in this case, 3, and b is in case your 4. But we need to match now up the top one, which is s minus a. So we need to do such a way that we'll get s minus a, which means s minus, s minus 3. Now to do like that, we are going to do this is plus. I'm going to break this basically 13 to, I need to take common 2. So, and then I need to have 3. So it's going to be 6 definitely. So if I take 6 from there, the remaining will be 7. So I need to break this as minus 2. So it's going to be minus 2, yes, and then 6, and then 7. Okay, will remaining minus 3 square plus 4 square. And interesting about the fraction is anything on top, we can use denominator as many times as we like. Okay, so we can split, if we're splitting the top portion. So we can say minus 2s plus 6 divided by s minus 3 whole square plus 4 square plus 7 s minus 3 whole square plus 4 square. So you can see here we are kind of getting the same structure which we're looking the formula. So if we take minus 2 from here common, we'll get s minus 3, and then here s minus 3 whole square plus 4 square. And same thing we can do here as well. If you look formula number 21, we just need b on top, which means if we can make the value of b on top, and that's not going to be hard in this case because we just need 4. So if you say 4 on top, s minus 3 square plus 4 square, but we don't have 4 in top, we have 7. So what we can say, we can multiply by 4 and divide by 4 like that. Okay, so once we have this whole structure, let me write this last time, and then we are going to apply our inverse Laplace. So we can take this minus 2 in front, and then left over is going to be s minus 3 over s minus 3 square plus 4 square. Then same thing here, I can take that 7 over 4 on top, then multiply 4 over s minus 3 square plus 4 square. Now I can apply inverse Laplace. So let me write the formula. So the inverse Laplace of 2 over s is going to be simply 2. Inverse Laplace of s minus 3 over s minus 3 square plus 4 square. You look the formula number. Which one is that? Formula number 20. No, yeah, formula number 20. So this is formula number 20. Okay, formula 20. It's going to give us nothing but e power 3t, and then what was that, cos or sine? We're going to get 20 is cos. So cos b value, which is 4t. And then lastly, inverse Laplace of 4 divided by s minus 3 whole square plus 4 square. So that's the formula number 19. So which is going to give you e power 3t sine 4t. Okay, and here we can say using or applying inverse Laplace transform, and we are going to get our final answer as y, which is in a smaller letter, which is going to be 2 minus 2 e power 3t cos 4t, and then plus 7 over 4 times e power 3t sine 4t, and that's the answer we're looking for our differential equation, which is given in top.